Hey guys, as I promised you in class, I'm going to show you this thorough, detailed explanation over here for how or why the symmetry is negative b over 2a. We kind of covered this in class, but we didn't really spend too much time on that. So hopefully here I can give some more clearer explanation and you can understand this one completely this time, hopefully. So firstly, the symmetry it only existed. So even though I put the turning point form and general form, there is reason behind that. But you need to remember like the symmetry only exists, well, not really exists, but we only really need it for only the general form, which is y equals to ax squared plus bx plus c. We only need this one because the turning point form. Remember what the symmetry is really made for. The symmetry is made for us to locate where the turning point is when we're sketching graphs. So that is why if you have the turning point form, which is already y equals to a x minus h to the power of 2 plus k. In this case, you already have your turning point, which is h, k. So you don't really have to find a symmetry because my symmetry already there in the turning point, which is the value h. So x equals to h. You draw the line, that is your turning point. Symmetry. So that's why I don't really have to. But in general form, you can see here, there's nothing alike the turning point form. Even letters are different. So only part we have is x, a, and squared. But they are not really in the bracket. So you can see in the turning point form, when we have these x minus h in the bracket to the power of square, what does it remind you? It should really make you think another term we've learned in year 10. So it doesn't matter you were in the advanced program or you're in the general program, we definitely touched this part already. So if I expand the bracket when we have a square outside, that is how something we call perfect square. So you can see these have nothing alike with the perfect square, but if I can make this back into the perfect square, then I can make the general form somehow related to the turning point form. So what I'm trying to do now is trying to find connections between these two different forms. So then I can do the comparison, then maybe in that case, I will be able to locate the value h. Even though I couldn't really make a number, but at least I can have some representing form for h in my general form. So that is why I need to completing square for the general form. And if I want to complete square, the first thing I need to do is I need to get a coefficient out from my terms. Because when I'm carrying a with me, it's going to be really hard to do any of the simplifying or any of the adding or subtracting. So that's why the first step for us is to take a out. So let's put a as the common factor and then everything else in the bracket. Okay, when I'm saying everything else in the bracket, what I really mean is the first two terms. The first two terms, this one and this one. The reason I don't really have to consider c at the moment is we know c is a number. It can be any type of number. It can be a decimal, it can be a fraction, it can be a whole number, it can be a sus, it can be a square root, it can be so many things. But in the end, that is a number. So when we have a number in this form, we know there's one very basic rule in math is if you have a number, that means I can easily subtract another number from this or easily adding up another number on top of this. So that's why c doesn't really matter what form you're going to have in the end. That's going to be a number, either larger number or smaller number. So that's why we can leave c outside the bracket and without touching it for the moment, because I don't really need that to confuse more of my completing square. So let's going back to these. Now if I'm only going to factorizing the term ax squared plus bx, that means I'm taking only going to deal with these two terms. So if I'm taking a out of ax squared, that means what I'm saying taking out of, what I really mean is divided by. So I'm going to use this term divided by a, And then what I really left is x squared in the bracket. And then for the second term, that will be very similar. So when we're trying to take a out of the bx, we don't really have a in it, but like we said before, taking out a term out of the bracket, it actually means divided a from that term. So that's why we have b divided by a, which is b over a x. So now we take the common factor out. The next step is for us to completing square. And how can we completing square? Since we already have everything x, b, a, whatever like terms already over here, I'm not going to use the original formula to confusing you, because that one has a and b as well. It's going to be really hard to explain to you. So that's why I'm going to directly use, I'm going to use another color. Oh no, that's not the one. Where is the draw? Yes. So I'm going to use another color, which is green, to show you that if I have something x plus, let's find a letter that is away from a, x, h, k, and c. So we have d. D is not used yet. So x plus d to the power of 2. If I want to expand this one, easily going to apply the same way like we did for the expanding perfect square. We have x squared plus 2dx plus d squared. And now let's compare this one with my bracket. Which term we already have? X squared already there, so tick, don't need to worry about that. And which part we don't really have, or they don't look the same, or they don't look similar, is the middle term. And then the part we're missing is d squared, so which is the part inside the bracket. So we already have two parts, but we don't have the third one. That is why we call this procedure completing squares, because we need to find another square before we can actually put everything factorized back into the form, into the bracket. How can I find d? So we know the middle term is, in my original formula, is 2dx. But then in my case, in my term, is b over a. So what does it shows me? It means these two terms actually are the same term. They're actually the same thing. They only use different letters to represent, but they are the same middle term. So that's why I can easily use 2dx equals to b over ax. And now we can just try to do a little bit calculation, do a little bit simplifying, and then try to find d equals to what. So in this case, x and x can canceling out, because x is a number that is definitely no zero, definitely non-zero number. Because if it's 0, y equals to c, and I don't really need to go through all this trouble. So 0 is a non-zero number. I'm talking about, x is a non-zero number, so that means we can easily dividing both sides by x. So dividing both sides by x, we got x over x, x over x, and then easily this one equals to 1. Equals to number 1. And then what else we have is 2d equals to b over a. Yep. So 2d equals to b over a. This very similar thing, because I'm trying to find d equals to what representing. So that's why I need to remove this number 2 to the other side. And how can I do that? Times a half. So divided by 2, what times a half? Times 2, times a half, then you got d equals to b over 2a. So you can see this part already very similar to the symmetry, but we have here is as negative, here as positive. So then I'm going to continue showing this to you. So now let's continue with the next step. We have y equals to a. Now we have x squared plus bax. Now we can completing the d squared. We know d is b over a, then d squared is definitely going to be b over, b over 2a, my mistake, b over 2a squared. And then, so these ones already being kind of made. And then you can see I completing square by adding b over 2a squared. But then this part is something I put additionally on top of that. If I literally just leave b over 2a squared in the bracket, that means I'm actually making this expression or this equation unequal because I'm adding something on top of it and haven't really taken it away. So I add that, and directly I need to take it away to make the whole thing balance. Because remember, you are just completing square, you're not really changing result. So that's why I need this part. Just help me to complete square, but instead of changing the whole thing. So then we have plus c at the very end. So now we can try to firstly completing the terms that we already made here. So this part, we can complete that. We can do the completing square. So a is still outside, but this case we have x plus b over 2a, and then bracket off to the power of 2. Then outside this bracket, outside the first bracket, which we completed the square, is minus b over 2a to the power of 2. And then after this one, we have c outside. So now, it still doesn't really make too much sense, but let's continue. Let's continue a little bit more by putting this number a back into the bracket. So we expand it because we are trying to make the general form and the turning point form somehow relevant. So now it's kind of relevant, but since the a is still stay outside the big bracket, the first bracket, we need to make it only have one bracket involves for my whole form, whatever. So that is why we need to times it back. So a and then x plus b over 2a to the power of 2. Then minus a times b over 2a to the power of 2. And then eventually plus c. Alright guys, so now here, I know it's very chunky. I know it's still very, very chunky. It looks a lot more than your turning point form. I know that. But then you can see at least now we have a. Now we have a bracket. Now we have the power. So it's kind of stay in the same form. So only the terms are different. You can see here we got plus k at the end, very end. That is why in the first step I said we don't really need to worry about c, because you can see now c is turned into this one, into all of these. That is my k. But do I really need to care about that? Since this one we are focusing on finding the symmetry, so that means doesn't really matter what the k value I have. I don't really mind. In the end, if I had to find symmetry, I can find this one easily from the general form. So all I worry about is the one inside the bracket. So now you can see here, x minus h. And here we have x plus b over 2a. So then the whole thing means this part, instead of giving me h, it actually gives me negative h. But remember, in the turning point form, I want to have the value of h. So how can I make that happen? Which gives me h equals to negative b over 2a. So that is the reason why the symmetry is negative b over 2a. So hopefully this time I explained the whole thing a little bit better. And if you want to see how we find the symmetry, just keep checking on this video. It's not really compulsory for you to know how we conduct the formula, but in the end, if you cannot remember how to find the symmetry, and this is a good way to completing square and find that directly instead of remembering that. So it's just some additional information, and the next video I'm going to show you one more example with the x-intercept form. Okay,